Welcome to another episode of Future Engineering Bets, where we look at the innovation of the future in advanced engineering. Today, I'm really pleased to welcome Mark Preston. Mark is the team principal of Lola Yamaha ABT in Formula E.
Your mobile phone, when you plug it in, it gets hot because you're charging it quickly. So as we put energy back into the battery, we do have to be careful of the amount you put in some circumstances. There's obviously an element of thermal management on the battery and not pushing it too hard.
But in the development cycle and the R&D development cycle, the power of AI potentially is huge in terms of defining futures, the simulations, 100x, a million x simulations that you can run, as long as you can extract from it useful progress, because it's always, there is an element of crap ideas in and you'll get crap ideas out.
I've been thinking about this quite heavily as to how it affects our process. So when I first started, and this is going back a long time, I used to have to go to the bookshop to figure out how to write a new piece of code to do something for my software program. It took me probably 80% of the time to write the interface, to then spend 20% of the time writing the software that was actually going to give me the insights into the race car. All of that is speeding up like a house on fire. So that's the most exciting bit for me. I'm calling it the friction tax.
My brain starts to tickle with things like if you could work out the current and future forecast temperature for the duration of the race, both air and track, presumably, and then humidity, and then the software is able to auto update, then the car can automatically be updating the driver, and for that to be just live being fed through to the driver to say whether that's a competitive advantage, the first person that gets to that fully automated module is the first team that can really exploit energy to the maximum, isn't it?
Yeah, maybe we'll use that one. Let's see if we can find a way.
Welcome everybody to another episode of Future Engineering Bets, where we look at the innovation of the future in advanced engineering, particularly in electrification in the motive and motorsport sector. And today I'm really pleased to welcome Mark Preston onto the episode. Mark is the team principal of Lola Yamaha ABT in Formula E. If you don't know anything about Formula E, you should get involved and you should watch it, because it's really pushing the boundaries of electrification in cars and energy management. And so, Mark, welcome. How are you doing?
Yeah, looking forward to having a chat with you.
Brilliant. And so, Mark, you have an extensive history in motorsport. For those that don't know you, would you like to just sort of whet our appetites with just a few of the Formula One teams and other motorsport things you've been involved in?
Yeah, so maybe going way back, I came over from Australia 1996, when Tom Walkinshaw bought Arrows Grand Prix. He had a facility and activities over in Australia, so I came over from there, joined them then, worked up my way up to head of R&D, running the test team at Arrows. After that, went on to McLaren, where I worked with Adrian Newey and Mike Coughlin on some famous cars like the MP418A, which was the only car that never ran. I call it the technology demonstrator now when we look back. And then went and did my MBA actually at Oxford and started to switch more across to I suppose you call it the business side of things, of engineering. And then went on to start Super Aguri Formula One team with Honda and Aguri Suzuki, which was great fun. We had to start the team in 100 days. So that was, something quite novel in those days. Went on to run that for a couple of years as technical director, and then started to look at what was the future of automotive and my world of, I suppose, mobility and our world of mobility, and got involved in the spin out of an electric motor company out of Oxford University called Oxford Yasa Motors, which is actually still running and is part of Mercedes now. And that got me interested in electrification even more. And then when Formula E started, got involved from the beginning with Alejandro Agag and all of the people at Formula E. Started again with Aguri. And so we had Amel and Aguri Formula E team in the very first season. And then we changed names to DS Techeetah, won then 5 championships total, 3 drivers and 2 teams. And then now we're back in Formula E as Lola with Yamaha as our partner. So that's a bit of a potted history, I suppose.
Wow. And a wonderful history that is, Mark, as well. And so many different race formats and types and probably regulations and boundary settings that you've seen in your career. And you've seen how it spins out into automotive and to other technologies as it goes through. So from today's point of view, we're going to talk energy management, which is a really key aspect of Formula E. Let's start off where Formula E principals like yourself, what's the biggest challenge you're worrying about as you go into a weekend in terms of how you're going to win that race?
Yeah, so what makes Formula E different to, let's say, my previous experience in internal combustion engine motorsport is that it takes place over one day. So you've got a very small window for a driver to and a team to arrive and basically hit the track in a free practice 1 and 2, and then straight into qualifying and a race. And it's quite a big difference to internal combustion, or let's say traditional motorsport, where you might have a Friday, couple of sessions on a Friday, then have overnight to look at data, then a free practice on a Saturday morning, then a qualifying in the afternoon, and then a race on Sunday with lots of big gaps in between. So we have to hit the ground running with a much smaller time period for the drivers to get up to speed and the engineers. So that really puts a lot of emphasis on preparation in the simulator with simulation and optimizing software before we arrive at the track. So it's a I see it as kind of like it represents a good place for what I would say a driver with explosive talent. They've got to hit the track and not make any mistakes, deliver what's necessary, qualify and go racing in one day. And so it's a high pressure environment and a different environment than other forms of racing.
Yeah, it really is, isn't it? And it has a mixed reaction from people, doesn't it? Formula E, in all truth, you're obviously very immersed in it, and some people absolutely see the brilliance in it, and some people are kind of very purist and argue against it. How have you seen that evolve over the last, I guess, 5 to 10 years?
Yeah, I think when you look at it from a sort of a fan's point of view, I think you can get caught up. I was listening to a podcast with Stefano Domenicali actually a couple of days ago about what's happening in F1 at the moment with respect to the electrification side of things. And he was very much focused on what is the fans' experience of the activity, let's say, and let's say not the engineers. All of us engineers love to play with all these amazing technologies, but a normal fan wants to watch motor racing. And so if you look at some of the best races that certainly I've had, where Antonio Felix da Costa won the race in Monaco, coming out of the tunnel, overtaking Mitch Evans, on the last lap of the race. Where I haven't seen an F1 car do that for God knows how long. And that kind of really super close racing is the exciting part of Formula E. So yes, you have the traditionalists. I grew up with V8 supercars in Australia, so I appreciate obviously those cars and how they go racing. But certainly Formula E has changed a little bit over the years, and we've adapted the racing formats. And I think we've settled on quite a good racing format now with duels in qualifying, so that throws up a bit of a difficulty for drivers because they get one lap to go at it, and they have to go up against their competitors, so they can make mistakes, and then you end up with a spread out grid, which is what everybody wants. Or let's say it's not the fastest goes first and then there's no overtaking in the race. There's some element of it's down to the driver to deliver it on the day. And then in the race we have something called attack mode, which is in some ways like a very short pit stop, but because we don't have fuel loads on board, and because we don't switch tires to different types of tires, it means that it's quite hard to predict when to take that effectively short pit stop in the race, because it's quite, I'll use the word probabilistic instead of deterministic in some series. So it throws up a lot of different elements into racing. And so if you're a purist, maybe you don't like some of the new formats, but as terms of some of the racing it delivers, like that example in Monaco, it's spectacular, and you're jumping out of your chair, shouting, shouting at the TV, I'm sure.
Oh, amazing, amazing. And when people look at the Formula One racing and the Formula E racing and the other forms now, the Extreme H and others, they're kind of looking for that inference on how it rolls over into real life practicality. And I know that that's what, Lola Cars are all about as well. But when we look at that rollover, what have you seen the biggest things that are really hitting the market in terms of Formula E and going out?
So maybe if I go back to my experience with Honda when I was in F1, I learned a lot from my colleagues at Honda in how they saw racing. And certainly their founder, Mr. Honda, he looked at racing as a way to improve the breed, but he also looked at it from a way to develop engineers, processes, procedures, and the things that you can carry over. So many of the times that I had discussions with them was that when you go to motor racing, the sky's the limit. You can push the boundaries. You can potentially use some of the more expensive technologies that are out there to solve a problem. Not saying that will directly go to a road car immediately, but once you know what's possible, so the art of the possible means once you know what you can achieve, sometimes it's possible to achieve that with a lesser cost component or maybe a different way of doing things. So the same is true in Formula E. We're pushing the boundaries. I was talking to an OEM that has been in Formula E since close to the beginning, and I said, "Did you expect to make so many gains in something electric motor that's 100 and something years old, an efficiency in the, let's say, 80% to early 90% ranges?" And he's like, "No, I didn't expect we'd get as far as we got." And so without competing at this level against other OEMs and really pushing the boundaries, they didn't know that it was possible to get up to the very high percentages of efficiency. And then they know what is possible, and then they know that they can take that over into the road cars. Another example was that there was a way of dealing with some of the high voltage systems on the car, and because in road cars you haven't had to deal with high voltage systems ever in the last 100 years of development. You come into Formula E running things on the absolute bleeding edge and find that some just simple procedures don't work as you would expect, and all of a sudden you have to understand how high voltage systems work in a car company, and that is a learning experience in itself. And so I think there's always elements that cross over. Not always does it the exact component crosses over, but certainly a lot of the processes and procedures and simulation methodologies and proof of concepts cross over. I mentioned earlier about the McLaren that I call the technology demonstrator. I do think that motor racing, when you look at what is a technology demonstrator, they really are the proof of concepts of what's possible, and that allows people to take things over to the road cars in that respect.
It does. You know what? There's a thing that I think motorsport people, especially the engineers like yourself, and you had a history of developing things. You understand that competitive engineering, and it was a word that came up at that recent MIA event that you were also a guest speaker at. That competitive engineering is something not to be underestimated. That in the pressure of design, build, test, design, build, test, design, build, test, which drives progress. When you set several different teams against each other and say you all need to go into a design, build, test cycle, it forces something out of people, which is creativity, brainstorming, and like you talk about the prototyping. For me, we used to use the word breadboarding all the time. Just
Mm.
let's get it on a breadboard, which is just, it doesn't need to look like it's in a pretty package. It doesn't need to be the finished article. We prove it, we prove the idea, and if the idea has some basis to do something, we then take it forwards and develop further. And in motorsport, it can be well underestimated for how it can really take. And you talk about the efficiency of the, let's say, the motors and maybe the inverters and what have you that have been used in Formula E. That's huge, isn't it? And when I like to think of the energy management, which we're going to come on to,
Mm.
then talk about how that rolls out, because the automakers, for what they invest in motorsport, in theory, if you do it right and you pick the right motorsport for you, all that learning can come out and help guide the early design phases and the requirement setting phases of your OEM product requirements, can't they?
Let me answer that first thing you said about competitive engineering, because a lot of people always ask me, "Did you race cars ever?" And I say, "Well, I had a go-kart with one of my best mates when we were younger and we were at university. And I realized pretty quickly I could make him faster than he could make me. So I decided I could be competitive by being the engineer that made him win a race. And so I kind of took that methodology forward as a really, this is my competitive advantage, is that I can figure out how to make a driver go faster. So that's what I've always focused on, instead of perhaps being a driver myself. But to the second question about elements that can cross over, I think, yeah, it's motorsport pushes everyone to the boundaries, because every 2 weeks or every few weeks you're judged against your peers, and in the big wide world, you have the answer. Did we succeed in our 2 week sprint between the last race and this race? Did we make an impact, or did the others make more of an impact? And so you get to measure yourself. Let's say your KPI is the lap time, and so every 2 weeks you get to see whether what you did last week made an impact. And I know that's certainly what makes it fun for an engineer, is that you get to see that answer every 2 weeks.
So when we look at motorsport and we look at, let's take Formula One as the example a lot of people use. There's a lot of R&D goes into Formula One in terms of how much of the car is actually developed individually from other teams. And then
Yep.
you move over to something like Formula E, where a lot more of it is preset and there's a
Yep.
single source supplier. Can you describe the difference between the two? Because when It's actually an interesting, and when you can constrain everybody to one set of equipment with only a few things you can really vary,
Mhm.
it drives other kinds of creativity than if you could vary everything.
So probably the easiest way to do this comparison is to look at the cost cap. So F1's cost cap is somewhere in the region of 150 million. Our cost cap is more like 15 million. And so that's all in the FIA documentation. So you can see that, which pretty much drives a 10 times difference in the amount of R&D and resources you have to deliver a project. So what was settled on very early in Formula E was that you would say, okay, let's not develop the monocoque because that's not a differentiator anymore. And it probably was back in the days when I started doing monocoques in the 90s, but nowadays it's not the differentiator in a road car. What's the differentiator is the electrification element and the software element. So, as you probably know, software-defined vehicles are the buzzword of the future of
Mhm.
automotive. In my opinion, Tesla is probably the leader in that in terms of road-going vehicles, and obviously a lot of others are chasing along behind them now. But the specific task was for the rule set was to make sure that competition was happening in the area that was the most useful to transfer across, or the best technology transfer. So the area that we focus on is the electric powertrain itself, and then the software and all the processes and procedures that go with that. If you know the classic V diagram in engineering, when you think about you start with a specification and then you obviously do all of the analysis and then you do the testing and you do an iteration loop. What you could say is a lot of people talk about shifting that to the left. We're doing more and more and more simulation, which is completely relevant to road cars because road cars are doing more and more simulation, more and more digital twins, and all of those buzzwords. And that's what for me is defining modern engineering, I would say, is that process driven element to it. So more simulation, more driver in the loop testing, more use of AI that's obviously coming really, really fast and is certainly of the moment. And what I think about that is quite funny is it's only of the moment in the last year or so. It's very
Really?
recent. But
Yeah.
that's really when these models have started to be able to do more and more. And so I think what we always try to focus on, I think, in motorsport is to be as relevant as possible to what's happening in the road car industry. And in my very strong opinion, software defined vehicles, AI, the whole development cycle is what everyone's talking about at the moment. Certainly in OEM circles, speed of development, model turnover, how fast you can do over the air updates, all those things are like the core of what's happening in the automotive world. And so I think Formula E focuses really, really tightly on that aspect. And that's what we compete in. So we're all trying to compete in the energy management element of that. We're trying to compete in the control systems, the way we can make the driver able to adapt to the car the most quickly when they arrive. As I said earlier, you've only got one day, so you've got to hit the track with the most preparation, with the most knowledge that you can to give the driver the shortest amount of time possible to get up to speed and compete with the others.
Yeah. And AI was a subject I was going to touch on actually. So as we go into the energy management piece, it's interesting you talk about it. I know that, well, every business is either using it or thinking of using it, but in the
Yeah,
development cycle and the R&D development cycle, the power of AI potentially is huge in terms of defining futures, the simulations, 100x, a million X simulations that you can potentially run, as long
yeah.
as you can extract from it useful progress, because it's always, there is an element of crap ideas in and you'll get crap ideas out type scenario. But so AI is something you're using. It's across motorsport already. Is it helping you in terms of as a lever against others? Does it stay the same as everybody uses it together?
So I think I did a recent article because I've been thinking about this quite heavily as to how it affects our process. And so I took a little bit of a reminisce about when I started programming. About a long, long time ago with Pascal back in the 90s. And that my best example, sort of where I've got to, is the knowledge asymmetry of an LLM and yourself is one of the most important aspects. So when I first started, and this is going back a long time, I used to have to go to the bookshop to figure out how to write a new piece of code to do
Mm.
something for my software program. So I started programming a simulation back in engineering in Monash University a long, long time ago. And the amount of time it took me to do the research to then get around to implementing it. And what I found also along the time was it was also just writing the GUI, the interface with yourself to actually input the data took me probably 80% of the time to write the interface, to then spend 20% of the time writing the software that was actually going to give me the insights into the race car. All of that is speeding up like, like a house on fire. So I'm finding personally, I dug out an old simulation that I hadn't touched for 15 years and thought, let me have a look at this. It was my personal pet project, and I put it into one of the LLMs, and within about 2 or 3 hours, I had a running version that was transferred from Visual Basic to the latest web-based tools, and I could see how quickly now, with the knowledge asymmetry with the model, how fast you could develop new ideas. So for me, that's one of the more
Uh,
exciting elements, not just asking it a question, please tell me the density of steel or something. It's more saying, I'm trying to figure out how to write this piece of software. I don't know how to do that call to a hard disk or something like that, or to a cloud service. How do I do that? And 2 seconds later, you'll have the answer. And it just sort of speeds up what I've been calling it, the friction around all of our jobs. And so that's the most exciting bit for me. I'm calling it the friction tax. So
I
the
like it.
knowledge asymmetry and the friction tax that I've got all these examples from the old days, which I can use in my thought process, but I've kind of tried to map that out. So that's just one element before we get into all the other data analytics and all of the other speeding up of using cloud tools, and that's just obviously a lot of things going on in the background. So they're the ones that are probably more, let's say, public domain. That's
Yeah,
obvious
no,
for
I
everyone.
understand it. And I imagine what will be very active now is because you're in these compressed time windows with a lot of things got to happen on a day, that AI will potentially make huge difference in gain between one session and another session that enables very fast data crunching and analysis.
So into that exact point, sometimes it's not the AI, for example, that's doing the actual crunching, but there might have been something there's certainly a lot of things that I dreamt about doing over the years, but never had the time or the inclination, and thought, you know what, I haven't got time to spend doing that piece of software that could analyze that piece of data in a different way. And I would have just put it to the side and thought, one day maybe I'll have a look at that idea. Now you can basically just do a long prompt, and within half an hour, you'll have at least a prototype that you'll be able to say, written in Python or something like that, and go, actually, that could work. And then you can perhaps go, okay, now let's take it a bit further. Whereas before you would have said, that's too much work. I can't quite see over the horizon whether that's going to be worthwhile doing. So, when you think about optimization, where you don't know where the local maxima or minima are, and you're thinking, I think I'm at the local minima, but actually over the hill is another lower minima, but you haven't got the bandwidth to maybe find new
Um,
tools and new concepts. So basically, now you can just say, run off 6 different ideas, just with a really large prompt, and then it'll come back with the answers. It's obviously garbage in, garbage out, and you still have to look at it. But what I think is it just opens up all these possibilities that you just didn't have the bandwidth to do, or maybe the resources or the people. So going back to your earlier question about sort of F1 versus Formula E, if they've got 10 times the budget of us, that means they've got 10 times the people. We want to see if we can use AI to augment the people that we do have.
yeah, as they will be doing as well to 10x their budgets as
Exactly.
well. Yeah. Absolutely. And so looking at the energy management side of things, and one of the things that seems really relevant in energy management today in the road car setting is getting the most range or long-term durability and performance out of the battery and the whole car. And
Yep.
as you see the different car companies with often similar battery techs
Yep.
getting different ranges in real world. And so, regardless of what the lab
Yep.
says and the lab test, and then a lot of that comes down to software, which comes
Yep.
down to energy management. Some of it's thermal, but we'll go
Yep.
also into the energy management side. And then when that plays itself back into motorsport, the challenge against your competitors and peers is who can refine the energy management cycle enough to get it working best. And just before I do hand over to you on that one to ask, well, the question is, how are you finding the energy management? Where do you push into to get that race cycle? Because for me, the cars have exploded in weight. One of the things that we've not got quite right in the transition so far is what was a 1600 kilogram family car has now become a 2.2 to 2.5 ton family
Yep.
car. And so the drive naturally will be through efficiency, through software,
Yep.
and understanding where your energy losses are in the overall system architecture, which might not be software, it might be other things, hardware, electromechanical, whatever. That must be the same things you're struggling with.
Yeah. So maybe I can use some examples from like the first season, because, just, looking back I remember our first season. I don't know if this is quite true, but I remember in the first races, or at least the first practice races, some of the drivers remember that their team was just like, okay, you've got this much energy. That means at end of every lap, you're just going to have to look on the dash and approximately say you've used 5% a lap. That was the early
Yeah.
days of everybody trying to figure this out, 12 years ago. And then we probably got a little bit further and we got a spreadsheet that we could at least, map out over a spreadsheet the usage every lap. And maybe it's not clear, but deliberately the FIA made sure that telemetry is quite restricted in Formula E to make it more difficult for us engineers. And so the driver has to tell us what energy the car's got every lap. And that's really just to create a more difficult situation, because otherwise we'd be doing way more optimization. Again, it's to do with budgets and to create more difficulty, as always, for the teams. And so in, let's say, the following years, the spreadsheets got more complicated. But then some of the drivers, like we had Antonio Felix da Costa as our driver in the first couple of seasons. And he figured out that, just as an example, when you're going through low speed corners where nobody can overtake you, you can just go on part throttle and actually save energy on the others who are on off their throttle, like a taxi driver, in London or something. And he found these extra bits of efficiency that we hadn't calculated. And so we're like, why do you always able to catch up, XYZ energy? And he's like, well, I think I just drive differently through the low speed corners than others. And we had a look at the data, and lo and behold, that's what he was doing. So over time, of course, that's got more sophisticated, and you add in more permutations and combinations and validations. But even now, we're still finding ways of optimizing energy, because once you've done that side of things, then you've got to worry about, at some races, you've got to worry about temperatures in some areas. And so you have to optimize how much regeneration you put back into the battery. So an example of your mobile phone, when you plug it in, it gets hot because you're charging it quickly. So as we put energy back into the battery, we do have to be careful of the amount you put in some circumstances. So there's obviously an element of thermal management on the battery and not pushing it too hard. So going back to your question about road cars, I think I actually had to do a trip yesterday. I did 2 runs to the airport, and different airports, and I was doing too many of the calculations in my head, looking at the screen and looking at my Google Maps and figuring out, and looking at the energy usage on the dash. Whereas in my previous Tesla, that was all calculated for you. And so there are elements where road cars are still quite different, and that's to your point of what's the temperature at the moment in the country, and that information can come from the internet, and what's your putting together all these elements of things together. So I don't think everybody's cracked it, because there's a lot of parameters still to go. And so part of it is also teaching our drivers when to use energy, how to use energy. This is what the system's trying to tell you, but if you need to overtake somebody, these are the parameters around how much energy you can use, and then how much you're going to have to save if you overtake a driver. So there's a huge amount of aspects that are associated with the energy management.
Yeah, really interesting, and really interesting on both sides. The energy management. I'm also interested as a motorsport fan on the driver's side to also
Mm,
think of what it must be like being a driver in Formula E when it's not just a car that you get in and drive it as fast as you can because you
yeah.
may not reach the end of the race. So there must be so much conditioning and discipline required in them.
You can imagine that at the moment there's quite a lot of discussions around F1 and Formula
Yeah,
E, as Max Verstappen's been making comments, as you know, and obviously I think it's public domain that a lot of Formula E drivers do a lot of sim work for the F1 teams. So there's a number of things that go backwards and forwards between the two elements. I found an article from 2015 on the BBC website that said it was about management back then. I think it was tires. And the question on the BBC was, has it always been about management of? And it's like, that's 10 years ago. So yeah, I think we've always been talking about management of. And I think some of the points were, in the old days, Alan Prost was better at managing the mechanical reliability of his car versus maybe Nigel Mansell. When it was a tire war, we had people who were better at managing tires versus their competitors. And so I think it's hard to find a time when you weren't managing, or the drivers weren't managing something, whether it's engine reliability, energy flow. You look in WEC at the moment, it's got an energy element to it as well, which provides a lot of interest in strategies over Le Mans and things like that. So I do think, I suppose one of the differences perhaps at the moment is that at least in qualifying, the driver is flat out. And then in the race, there's a lot of energy management. But in terms of if there's safety cars and full course yellows and other things that affect the race, there is also elements of races that are flat out as well, depending on the things that happen in a race. I think it does reward the drivers that are really good, large active capability that
Mm.
can think around all the things that are going on in a race and understand the energy usage. Like I said earlier about Antonio and certainly with Lucas de Grassi, those guys have got a massive amount of capability to be racing, but then also asking us questions on the radio. What if this happens? What if that happens? What if I use energy now? I reckon I could get past these guys now. Can you quickly do a calculation and tell me if it's going to affect too much the end of the race? So a number of the drivers that have the capacity to also be asking questions and giving us feedback to say the race is playing out like this. I think I should be going past people. You guys tell me if that makes sense. And then the strategy guys do a quick set of calculations and either say, yes, good idea, let's go, because the drivers are reading what's actually happening in the race as well. Perhaps it's not completely clear to us in the garage.
Mm. Fascinating, isn't it? So it's fascinating to think, and like you say, there's the Max Verstappen's all over the news at the moment, but I think partly because there's not a lot of Formula One going on because of the break, so it's just
Yes.
being circulated around and around as
Yeah.
the most popular topic that they can come up with.
Yes.
But when you look at it in terms of energy management and going into the electrified world, it's interesting. You said even your older Tesla
Yes.
had features that your current car doesn't have, and that's from a UI point of
Yeah.
view, from
Yeah.
understanding it. But when you're looking at the OEMs and where they're pushing, presumably you in motorsport, and obviously when you're in cars and looking at sustainable tech, is where are the biggest pushes in terms of energy management in the future? Is it in the battery management in itself? Where would you say the biggest challenges are faced?
I suppose my joining the comments about AI together with this thought about modeling, I've always found the more you understand something, the more you can make a model that perhaps is closer to reality. One of the aspects is you'll see in some of the road cars, certainly the Tesla can preheat the battery if it knows you're leaving the house at a certain time. And so it just brings the battery, as you know, into a more efficient range. But that's done automatically on the Tesla. But other cars are not quite so forward looking. And I think when you think about the software defined vehicles, so I'll give you an example from F1. When we first did active differentials a long, long time ago, we were very hesitant because we were saying, okay, the active differentials are going to be more expensive and it's going to be all this extra software and complexity. But actually, what happened was we reduced a whole lot of complexity when we did active differentials because we didn't have to have 20 different types of mechanical diff available to be spares and sitting around
Mm,
at the racetrack. It meant that we could make changes last minute to the way the differential worked so we could do effectively over the air updates to the car. And so all this flexibility was opened up by having an active software defined element to it. So I think what existing, or let's call it legacy OEMs are finding compared to, say, a Tesla who's been able to reinvent their entire system, is that the Tesla's been designed with active control in mind, whereas a legacy OEM may be still sitting with I think Jim Farley made the example of an electric window winder or a controller that's completely separate to the core CPU of the car or
mm,
compute of the car, and let's say a seat. Just to use some examples of things that don't need to be active but could be active. And I think that's where the software defined element of it is really suits racing. Because in motorsports, we want to be able to make changes to the absolute last minute. Maybe it's a bit risky to say 10 minutes before qualifying, but the day before first practice, an update comes from the driver in the loop simulator, tested in the factory, and we decide, is it worth the risk to put that on in free practice one on one car? And maybe we do it on the out lap and the in lap to check that it works as per what's been defined, and hopefully all of our processes and procedures are rigorous enough on the hardware in the loop system and the driver in the loop system back at the factory that we've minimized risks enough that we can do effectively an over-the-air update a few hours before free practice one. And so I see all of that really similar to road cars, and I'm going to say almost finally road cars are becoming capable of accepting these updates the last minute, let's call it.
It's a really fascinating area, the software updates, over the air updates. Assuming that companies were always putting the customer first, you could
Hmm.
even imagine a world where you'd buy a car and the range may even get longer
Yep.
over the next 6 to 12 months as
Yep.
they release software updates. Now, you then take the customer first view away from it and say, well, no, they probably wouldn't do that because they'd want to put that in the next model and make you sell the
Yep.
car and buy the next model as the way it goes. So with energy management then, presumably this then rolls into the hardware within the car and vehicle, because I know there's quite a difference sometimes between, let's say, a Tesla, who have been very forward with their hardware and architecture in the
Hmm.
car. So, and then maybe the more traditional OEMs that maybe still using a lot of energy consuming hardware, maybe the way the communications are handled or the wiring's handled or the sensors.
Yep.
And it's still an area that can potentially consume quite a bit of energy
Yeah.
through the life cycle of the car.
Yeah, I probably haven't got a good example of that. Although I do know our competitors, Jaguar. If you do have a look at, I think on their website, they say that something they've learned from Formula E, they were able to update on the iPace, I believe, to deliver a better range on a battery that was already in manufacture. So I do think that there are. So let's say when you first develop a battery, and I'm not a battery expert, but when you first develop a battery, you've certainly done a certain amount of validation, durability testing, and everything, and you're happy that it meets the requirements, let's say the base requirements of the OEM standard. But then you, let's say, learn something in Formula E and realize, maybe you could push that cell harder if you knew more accurately or could predict better the air temperature. And then you think, okay, can we take more of a risk on knowing the air temperature accurately and the air temperature over this drive that this person's going on? Perhaps you could make a modification to one of the parameters associated with regen, let's say, because as we spoke earlier, maybe you could put more regen back in the battery than you were, and as long as you could predict a little bit further forward, and this is where potentially AI and machine learning comes in. As you look at the time that car's out in the market, you can start to take a few more risks because you understand it better, and you can change some of your parameters. And so in motor racing, you could see the art of the possible and say, wow, this is possible in Formula E. Let's see if we could find a way in a road car to mimic that learning. So I think there's still ways to optimize even when
Mm.
the hardware is fixed per se.
It's really interesting subject area. Just diving into that because my brain starts to tickle with things like if you could work out the current and future forecast temperature for the duration of the race,
Yes.
both air and track, presumably, and then humidity,
Yep.
and then the software is able to auto update, as
Yep.
in it can take the current temperature of the race car is telling me. We've got an ambient
Yep.
air sensor, so we know what the ambient air is. Then the car can automatically be updating the driver and saying, well, basically, you're either going to be able to carry this race cycle to the end of the race and be okay, or maybe there's more energy, because of the changing conditions. And for that to be just live being fed through to the driver to say, actually, whether that's a competitive advantage, the first person that gets to that fully automated module type that the driver can be kept up to date is the first team that can really exploit energy to the maximum, isn't it?
Yeah. Yeah, and I think all of these ideas can keep adding. Maybe we'll use that one. Let's see if we can find find a way. But yeah, you can imagine over a WEC program like that's running a hybrid system over 24 hours. That really does the temperature really does change a lot. Of course, obviously in middle of the
Oh,
night.
huge, yeah.
So the those all those elements about predictions. Now maybe you predict forward and it doesn't end up the way you thought, but then you're just going to have to make a different change to the system if it doesn't turn out as you thought. But if you make the bet, let's say, and on your tools, and then someone else doesn't, that's obviously always the best way of doing it in motorsport.
Fantastic. Well, Mark, it's been wonderful to talk with you today and really enjoyed talking about motorsport, Formula E, electrification, and the OEMs and the impacts. Tell us more about the Lola Car project with Formula E and tell us how people can find you and where to see you.
Yeah, so if the fans don't know, Lola's back after 10 years away. It wasn't racing for 10 years since 2012 till 2022. We've come back in the World Championship, obviously Formula E, which is at the highest level of motorsport in the world, but on the obviously the electrified side of things. We see the future, being very much multi energy world. Obviously, we hope to get back into Le Mans. That's something that Lola's got a deep history with. So we think that a lot of the technology that we're developing in Formula E is quite relevant to series like Le Mans, obviously relevant to F1, although we're not going back to F1, but that's the kind of area where we feel that there's a lot of crossover in technology. And given that it crosses over with a lot of road car elements that are out there in the world, all the learning that we're doing here is super important. We just released a T70S, which is based on the original T70 from the 60s, which is it's a fully sustainable car. There's all sorts of elements you can check out on the website. So lola-cars.co.uk, you can see and you can get links to all of the elements that we're doing. And obviously you can see us on all of the normal channels, Instagrams and Facebooks and LinkedIn as well. So yeah, do reach out if you have some more interest in what we're doing at Lola Cars.
Fantastic. Thank you so much, Mark. And if you've enjoyed this episode, make sure you share this with somebody you know, follow and subscribe. And remember, Future Engineering Bets is all about looking at the future innovation in advanced engineering and looking at where people are going to be investing their capital, where they're going to be seeing their return. My name is Fred Warner, and I'll see you again in the future.